Okay, today's lecture is going to be calculating the finished openings for an L-shaped winder stair. You can see up in the upper left-hand corner, I have some dimensions there for you. We need those to make some initial calculations, even at the beginning and down the way a little bit. So first of all, the total rise will be 3,180 millimeters. The unit rise will be equal to or greater than 180 millimeters, but as close as possible to that number. For unit run, we'll be using the 7:11 proportion. The floor thickness of the main floor is 330 millimeters. We're shooting for a headroom of 1,950 millimeters. The nosing is 25 millimeters. The riser thickness and wall finish and header finish thickness is 13 millimeters. And the kite riser will be 6 risers down. I'll just number these off for you so you can see that. 1, 2, 3, 4, 5, and this is number 6. And so I'm just going to turn on a couple of the layers here. So you can see that this purple triangle represents the finished opening. In particular, this measurement here is the finished opening, and we'll refer to that as finished opening A. And this next triangle then represents landing drop. And the way we're going to utilize this is this line here will be our headroom. So that goes to the line of flight. And we'll be calculating the size of this length here, and we'll be adding it to the size of the landing. And that will give us finished opening B. Here at the top of the first flight, finished opening A, we see that we have a riser here, thickness, and that riser thickness is 13 millimeters, and we have a nosing here as well, and that nosing is 25, and that carries on, of course, throughout the stairway, a nosing of 25. On the header, as we go down the stairs, we see there's also a finish on there. And this is going to be 13 mil finish. And you can see we have a double header here. Notice also that I've already created the layout on the floor. And this is true to the actual stair we're going to be calculating today. So I'm just going to remove all this stuff. And we can begin with the floor layout and some of the calculations that we need to do here. So we're going to begin by calculating the actual unit rise. We'll start with the total rise of 3180, and we'll divide that by the 180. And that comes out to 17.7 risers. Obviously, we can't have that. We're going to, if I rounded this up to 18, I would have a unit rise lower than 180. So based on the parameters of the initial problem, I'm going to divide that by 17 instead. And the result is a unit rise of 187.1. And now I'll just tuck that up here in the corner, so that we can easily refer to it down the road. Next step is the unit run. And as I pointed out earlier, we're going to be using a proportion of 7:11. Now that I've calculated the unit rise, I'll put that across from the 7, which indicates the rise, and I'll calculate for X, and that will give me the unit run. X in this case is equal to 294.0. And I'll pop this up here. So what we see now is a unit run of 294.0. So this is 294.0, and this, and so on and so forth, all the way up and down the stairs. Now, as previously mentioned, we consider this to be equal to 450 millimeters. And so my goal at the moment is to find out what this offset point is. What is the distance or the dimension of the offset point from the inside wall? And the process goes something like this. If you take note, if I had the radius to this point, and if I subtracted the 450, I would find out what this number is here. Well, the way we go about this is because each of these unit runs is 294.0, then this is also 294.0, and this is all the way around. So if you can imagine a large circle being formed around here, like this, then you realize that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arcs, which are 294 millimeters each. That will then give me the circumference of this circle. And to find the radius of a circle, when you have the circumference, you divide by 2 pi, which is equal to 6.2832. The result is 561.5 is equal to the radius of that circle. So now all I have to do is subtract the 450, 561.5 minus 450, and that will give me the offset of the layout point. And this is equal to 111.5. And I'll take note of that. Our next step then will be the stair width is 950. I guess I might have forgotten to give that to you at the beginning there, but the stair width is 950. This dimension is the offset, or 111.5, which means that if I add those two numbers together, I will find out what my landing width is. And the result of that is 1061.5. And if you take note, this landing is square, so it's 1061.5 in both directions. Okay, let's carry on with finished opening A. So where does our calculation begin? Well, first of all, we know now that this landing here is 1061.5. So that's been established. And we can clearly see here that because the kite winder is 6 risers down, that means that we have 1, 2, 3, 4, 5 risers to this point. However, it means that we have 1, 2, 3, 4 treads, which will take up the rest of this distance. Sorry, to this point here. So this will be 4 times 294.0. So I'll just do this calculation over here. 294.0. I will add that to the landing distance, 1061.5. And that will equal finished opening A. And the result is 2,237.5. Okay, but that isn't where we want to go with this. We want to take into account that when we're framing this in the floor, that's really the number we want to know. And so I want to know what is the distance to the face of this header, and what is the distance to the face of this framed wall over here on this side. Now, at the beginning, you recall that I said there was a 13 mil finish on all walls. And up here, I said that the nosing was 25. and the riser thickness was 13. So in this area, we would have 38 millimeters, which is also known as top attachment. And over here, we'd have another 13 millimeters. So 2237.5 plus 38 millimeters for top attachment plus a 13 mil for drywall at the other end. And this will result in rough opening A. So rough opening A, from this here I get 2288.5, and it would be appropriate to round that up to 2289 millimeters. So let's pop that up here. ROA equal to 2289. Okay, opening B then. And this is where things seem to get a little bit tricky for most students. And so let's begin, first of all, by defining some of these heights. For example, this distance here then is the headroom. That's all the way to the line of flight. And that's equal to 1,950. Our floor thickness up here was 330. And so if we add both of those numbers together, we end up with something called drop to line of flight, which is the full distance. So drop to line of flight is equal to 1,950 plus 330. And that is equal to 2,280. And I'll just make note of that now. The fact that I placed this woman here on this last flyer is not by coincidence or for some sort of hilarity. The reason I've put her there is because when you are standing on this last flyer, you've already gained a certain amount of headroom. And so as you begin to head down the stairs, you don't need to have as much headroom gained. So in other words, now that I've stepped down onto this flyer, that vertical distance needs to be taken into account. So we will take the drop to line of flight, the full distance, and we'll subtract the distance from the top of the floor all the way to that flyer. So it's minus, remember that this riser here was 6, therefore I'm going to subtract 7 times the unit rise of 187.1. And what that will give me is the distance from here to here. And that number is 970.3. And now you'll see what the value in this is. This large green triangle represents a perfect proportion of the unit rise, unit run triangle. And so because I know both the unit rise and I know the unit run, I can compare it to this larger triangle. And we just calculated this distance to be 970.3. So that's a vertical dimension. I'll place that opposite my unit rise. And let's calculate for that. And for x, this is equal to 1,524.7. So my calculated distance right here is 1,524.7. Do you remember in the previous calculations, we calculated the size of the landing, which is from the outside wall to this point, and this is 1061.5. So I'll add those two together. And I'm getting 2,586.2. And just like finished opening A, we have to take into account this header finish here. So I will add 13 millimeters to that. And there's a wall over on this side here, just like there was on finished opening A, and that is also 13 millimeters thick, the drywall. So I'll add 26 to that number. And rough opening B then will be, rough opening B will be equal to 2,612.2, and that we can easily round up to 2,613. So rough opening A is equal to 2,289, and rough opening B is equal to 2,613.